So here is the problem 15 of the Project Euler lattice path. Starting in the top left corner of a 2 times 2 grid and only being able to move to the right and down. There are exactly 6 rows to the bottom right corner. How many such rows are there through a 20 times 20 grid? So if you want to actually travel from 2 to 2, there are 6 ways. So how can we count them? So there are 2 2 to the down, 2 to the right. So we have to move 2 down and 2 right. So if you have studied combinations, then you probably get the idea. So there are 4 places. 2 of them are supposed are, and other 2 are supposed to be down, or D. So what we have here, we have to choose in 2 locations for 2 R. So C of the combination of 4 and 2 is 4 factorial over 2 factorial times 2 factorial, which is 6. And if you check the question, the sample in the question, it also says that there are exactly 4 roots to the bottom right corner. So we have to find a way to calculate C of N and R. So to calculate the combination of N and R, we can use probably the thing that you all have learned in your high school, which is named Pascal triangle. So Pascal triangle is something that looks like this: 1, 1, and 1, 1, 2, and 1, 1, and then the sum of 1 and 2, which is 3, and then sum of 1 and 2 again, 3 and 1, and so on and so forth. So what this gives us? So if we try to manage it, this is the first row, this is the second row, this is the third one, this is the fourth one. So what we have here is this is going to help us to find the combination of choosing R out of N. And this by itself looks like a dynamic programming. So by knowing the Pascal triangle and its relation to finding the ways of choosing R out of N, we can just see that this is a dynamic programming. So we have a DP problem. And what we know from the Pascal rules of choosing, we have the C of n and r plus C of well, we can try to see if it's right or wrong. For example, choose if we initiate n as 3 and r as 2. So C of n and r, choosing 2 out of 3, which has 3 ways, and then C of n and r plus 1 is equal to choosing 3 out of 3, which is 1, and we have C of n plus 1 and r plus 1, which is C of 4 and 3, which equals to 4. And we see that this value plus this value is 4. 3 plus 1 is 4. This is just an example. So if we want, we can prove this very easily by just putting the values. Right? Just use their formula to calculate the number of ways to choose r out of n, and then that's it. You can very easily find the answer. That you can easily prove this formula. So I'm gonna use this to make my dynamic programming goes on. So I choose the function name as C just because it was the question of choosing. So choose to start with C, I choose C. N and M. N is the first number and M is the number of things that we want to choose from N. And because the number is going to be very great, so I used long. And first, I initiate all values as 1. Oh, I'm sorry. So we know that C of n and 0 is always 1, and we know that C of n and n is also 1. So 1 is for this one and the other one for the other one. So how are we going to calculate each number? As I mentioned, by, I guess, Pascal. For combination. Yeah, Pascal is, well, from here you can study more about the Pascal triangle, and this was the formula that I was talking about. So we can use this to calculate the other value. And this is how the Pascal triangle is created. So each value sums up together to create the one that is below those two. And in this way, the triangle is created. And this is using this formula. So we can use this formula to create this triangle in our table and use it as a way to find the combinations. So C of n and r is equal to C of n minus 1 and r minus 1 plus C of n minus 1 and r. Right, then I loop through the table through I and j. And I find the value of I and j by I minus 1, but by the number of ways in I minus 1 and j minus 1, which is this, and plus I minus 1 and j. So we want to actually rewrite it as a way we use in calculation is this. I and j equals to C of I minus 1 and j minus 1 plus C of I minus 1 and j. And then I return the value. So in this way, I create the whole table. If I want to use it again, I can just put this table outside of this function and use it whenever I want, if I want more than one value. But here, because I just want one value, I can just put it there because it's gonna create only one number. And that number, and now we should find a way to find that number. You know that this is a 20 times 20 grid square, and we want to find a way from the top left to the bottom right. So we know that it is a 20 grid. So we have to move right to 20 right. So the question actually wants us to calculate C of 40 out of the ways of choosing 20 places for right out of the whole 40 places. So we just need to calculate it using the function we write up there. So that's it. If you try it, the answer is this, which is just the same as the answer here, which I solved it. So this is the way to solve this question. And I hope you enjoyed it.